welcome to my project Optimizing Solar Energy Production with AI and Edge Computing. Uh, this is a project that I have done for my final AI project management, product management. And the first one is in the assignment task analysis. In the task analysis section, we have the problem description. So the problem is the energy produced by solar energy is not optimal. Energy produced has fluctuations due to factors like weather condition, time of day, and season. Energy blackout occurs because of inefficient production and consumption of solar energy, and quick battery death due to optimal energy and not optimal energy production. So this is a problem that we are having. So we are trying to solve or help solve these problems in this project. Okay, so when we come to the key tasks, what we have is analyze and show real-time energy production and consumption of the solar energy, predict the energy production and consumption so users can optimize their usage and schedule of energy production and consumption, and to recommend the predicted optimal energy consumption for the users. So that's what we are the system is going to help the users. So when we come to the task analysis, we have some basic tasks. We have turn off and on some devices and sensors in the system. We have to monitor the energy, and we have to show and predict energy usage and analyze, of course. So some of the basic tasks are data collection, future engineering, model design and training, systems testing, model retraining, and edge computing. So when we come to the second part of our assignment or our task, that's the user experience design. So how should be the user experience, or how should the user interact? So what I have thought is the system is going to be easy to use, graphical based analysis and prediction. We will have dashboard analysis and prediction for the user, and easy to interact, and simple buttons that can help user to interact with a minimal interaction. What will be the input information in the input design or the system design, the user interface design? So the input is mainly recorded from the sensors with the edge computing. So there is not too much work the user has to insert. So there is weather information, there is energy production data, and there is energy consumption data. So what are we doing is the weather information is collected through the sensor. The energy production is collected from the solar energy panels, that is from the sensor put there, and the energy consumption is from the consumption that output in the battery management system. So that's how the system is managed. So I have created a basic user interface design, a prototype design using Python. So it looks like this. So the power input, here we have the power input, the reading of today, power input or power usage, PV wattage, and average temperature, and graphical energy usage. And we have energy prediction for the coming 7 days, energy power input, power output or power usage, PV wattage, that's the watt from the battery or from the solar, I mean, and the average temperature. So that's the basic design that the users are going to interact. It's really colorful, interactive. and nice design. So when we come to the model transparency in the interface, in the user experience, users will be given user education and training that enables them to use the system and how it's working, the explanation of inputs and outputs, the basic system documentation for the user, so what data is collected, everything, and basic user interpretation, so how the algorithm basically works, is interpreted or defined to the user. And when we communicate the uncertainty, we explain the confidence percentage to the users. That's we are based on the weather, the energy input, and the usage forecast. We explain the confidence rate. That's 95% confidence we will say to him. That's 90% probable. So that's how we will explain the uncertainty. And there is a text explanation of the conditions. Probably there will be sunny, so we will have this much input power and this much usage. So that's how we will communicate. And the third question or assignment is privacy considerations. In the privacy considerations, we have privacy issues. That's personal data collection, PII, personal identifiable data. That is an issue because if we are handling that data, so we have to be, it can be an issue. And data security and sharing, who we share to, it's an issue, and how we secure the system or the PII or personal identifiable information. This is a serious thing to consider. And there is a data retention and disposal. What data are we collecting? Why are we collecting it? And when will we dispose it? Until what time will be available with us, or why will be available for us? So when will we dispose it? So this is a serious privacy issue to consider. Um, so how we tackle the privacy issues is private data is secured, especially the PII information. We will have to secure it seriously. And then we inform the customer why and how data is stored, what data is collected, how it is stored, and why it is stored with us, for what purpose. And we will comply with the FAIR, or that's the GDPR if we are operating in Europe, with the CCPA if we are operating in US, and accordingly to if we are operating to other countries, we will all comply with their FAIR or privacy rules. And then we will store personal identifiable information securely. That's PII, we have to be secured with encryption or something. And we don't share the information with third party without the consent of the user. Or if it's not necessary, we totally do not share information. Then we will have the fourth topic, which is ethical considerations. We have a source of bias. What could be the ethical considerations? One of them is bias. So what are the sources of bias? Train the system based on some demographic data. So if the system is biased with the training data is biased with some demographic data, which is specialized or more concentrated with some community groups, some age, some gender. So we will have some issues of bias in our prediction. And the privacy issues, data sharing and protection. This is also another serious issue. And then transparency. If the model or the algorithm is not transparent enough, so we will have privacy issues. And if we don't protect the data securely, we will have data sharing issue or protection issues. So we have another topic, which is fairness, accountability, and transparency. So when we come to fairness, what will we do to make the system fair? So we will have to follow how to do fair data collection, The data collection should be consider all the demographic groups or without bias, and the development of the model, that is future engineering, data engineering, everything should be fair model development. And then in the model update and prediction, we have to be fair on the uh, model. And then when we come to accountability, so everything should be accountable. So there should be model audit, and there should be dataset documentation, why is everything done, and the model documentation, how the model is built to achieve the specific purpose, and explainability. The model should be explainable enough or interpretable enough. How the system is coming into decision, or the model is getting the decision or the output. It should be explainable. And transparency, user training and education is one of the being transparent to the users. So we have to be transparent by being by giving training and education how the system is working to the users and developers, and the model explainability. Uh, so we try to the maximum to explain to the user how we are coming to the end of the decision or prediction, and the interpretation of how the features are used to make the model prediction. And then the data collection, why, and usage of the data to the user should be seriously done. We have to collect which data, what features are collected to what time, and why are they used, have to be explained. So thank you. That's the presentation.